Hello and welcome. In this video, I'll be solving grade 10 trigonometry questions, and let's get straight into it. Right, so the question 5 here, it's saying that in the diagram below, P is a point. So this point has got a coordinate, has got coordinates x and y, right? So these are the coordinates x and y here. And if you take a look at the coordinate from the origin, the x coordinate, it was to the left. So this is the x coordinate, and the y coordinate, it's going down. So these things form a triangle, right? Which is a right-angled triangle, right? So P is a point on the third quadrant, right? So we can look at the quadrants here. This is the first quadrant, right? And this is the second quadrant, and this is the third quadrant, right? So I hope you guys understand what it means by saying the third quadrant, right? So the fourth quadrant, it's this quadrant over here, right? So this space over here, right? So the space over here is the first, and the space over here, it's the second, and the space that is being occupied by that diagram, it is the third quadrant, right? So ROB, it is the angle, right? So if you take a look at this question 5.1 here, we are given ROB, which is the angle, and we also given 17 cos beta plus 15 equal to 0, which is an equation, right? So they're saying that we need to write down the values of x and y, right? So if you take a look at the P coordinates here, we have the x coordinate here and the y coordinate there, right? So we don't know them as yet, but we know that the angle beta, we can just put it there, right? So if I can draw the diagram here, 5.1.1, if I can use this equation here, the equation is 17 cos beta plus 15 equal to 0. So we can just make use of this equation by transposing 15 to the right hand side, and it's going to be 17 cos beta, which is equal to minus 15. And what we can do here is to divide both sides by 17. So we have solved the trig ratio of cos beta, right? And the cos beta, it is equal to the adjacent. So from the SOHCAHTOA here, so from the abbreviation SOHCAHTOA, we can see that the sine is going to be the opposite side of the angle over the hypotenuse side, right? And then the cosine, or which is the cos of the angle, it is just going to be the adjacent over the hypotenuse, and the tan being the opposite side of the angle over the adjacent side to the angle, right? So the one we're dealing with right now, it's the cos. So it means that we will be dealing with the adjacent side over the hypotenuse. So the adjacent over the hypotenuse. So looking at the diagram here, the adjacent side, which is the side next to, it is this one here, which we have the value is minus 15. So you can see that the x value, before we move, the x value is just equal to minus 15, right? And the hypotenuse side here, based on the diagram, the hypotenuse side is the r, which is this one. So I'll put the r there. You can see that the r here is the hypotenuse side, and the value on the trig ratio, it's given, it's just 17. So the missing one here, it's the y coordinate of the point, right? So from the trig ratio itself, what we were able to see was the value of x, which was the adjacent side, and the value of the r, which was the hypotenuse side, right? So we couldn't see the y coordinate, but we saw the value of r, right? So let's move on. The opposite one, it's the one that we do not know, and the r here, it's 17, right? So let's quickly use Pythagoras theorem to find the missing side. So that triangle looks more like a triangle that is having one side missing, so we can just use Pythagoras theorem quickly just to calculate the side that is missing. And if we do that, x squared plus y squared is equal to r squared. We say this is what? Pythagoras theorem. So this is the Pythagoras theorem. So this is the reason why we're doing that. We're making use of the Pythagoras theorem. So you can see that the x here is minus 15. I square it, and the y coordinate is not known, is unknown. That's what we're calculating. I can square the 17 also this side. So you'll see that here you'll get 225, which is 15 squared, negative 15 squared, and the y squared, this is going to get 289. So the y squared here, we will get 289. When we transpose the 225 that side, we'll get 289 minus 225, which gives us 64. And what we will do is just to square root both sides, introduce the square root both sides. And what the square root does is just remember that after introducing the square root, the answer that we get here is a plus minus. So the square root of 64, it's simply 8. And looking at the position of the quadrant, it's the third quadrant, the x is going to be negative and the y is also going to be negative, right? So since it's going down, so the point was moved to the left. So to have this point P here, we move to the left from the origin, and we move down. So meaning that both our x and y coordinates are going to be negative. So the y coordinate here, it's going to be negative 8. So it means that here we've already solved the problem, right? So we have the value of x, r, and we have the value of y. So let's quickly move on to the next question, 5.1.2. The next question, it's saying that without the use of a calculator, without using the calculator, determine the value of sine beta, right? So the sine beta, based on the triangle here, we will see that we have all the sides known by now. So this one is 17. So I have a triangle that looks more like this. So if you don't mind, you can just draw the triangle, just to redraw the triangle, and have the beta angle here with the 90 here, minus 8 and minus 15 here, with the 17 as the hypotenuse side, right? So we can answer any question here. They're looking for sine beta. Sine beta is the opposite over hypotenuse. So the opposite one to the angle, we look at the angle, and then we look at the opposite side to the angle, which is minus 8. So it means that the sine of beta here, it's going to be minus 8, and the hypotenuse side, it's the 17, which is the one opposite to the 90 degree based on this triangle, right? So we've looked at that, and we can move on to 5.1.3. So 5.1.3, they want us to determine the value of cos square 30 degrees times tan beta, right? So the 30 degrees and the 60 degrees, these are special angles, right? So we can quickly draw a triangle, a special triangle here. So if you want to draw a special triangle, just recall that the sine of 30 degrees, it's 1 over 2. The sine of 30 degrees is 1 over 2, and you can use this to draw the triangle. So it means that the sine theta, since sine is opposite over hypotenuse, it means that the one at the top here is the opposite side, and this is the hypotenuse side. So the opposite side to this angle, it is 1, and the hypotenuse side, it is 2, right? So I think another thing that you might as well recall is the cos of 30 degrees. Cos of 30 degrees is root 3 over 2. And if you use also that to complete the triangle, you will notice that the one at the top here, it's going to be the adjacent, and the one at the bottom is the hypotenuse, right? So here we're just doing this just to draw the triangle, and the adjacent, just to complete the triangle, and the adjacent side is root 3, and the root 3 it's going to be here. And now we can figure out the special trig ratios. So the trig ratios that are having special triangles, 30 degrees and 60 degrees, right? So we can just say our 60 degrees is over here at the top, so we can just put it there, right? So you can literally do anything with this triangle. You can evaluate trig ratios that are having 30 degrees and 60 degrees, right? So in this question, I think if you might have recalled that the cos of 30 degrees, because the instruction said without using a calculator, if maybe you have recalled the trig ratio, you would have looked at the cos 30 as √3 over 2, and you square that times. So the special triangles, the special angles, trig ratios can be evaluated from the special triangles, right? So there's also another special triangles for 45. We're not going to talk about it now because we needed only the 30 degrees, right? We will discuss it on the coming questions, right? On the questions that are that we're going to do after this. So the tan beta here, it's going to be based on the diagram that we drew, and you can see that the tan beta, it's opposite based on the SOHCAHTOA, it's opposite over hypotenuse, right? So if the tan beta, it's opposite over, so it's opposite over adjacent. So if the tan is opposite over adjacent, it means that it's going to be -8, which is the opposite side here from the beta, and the adjacent side, which is the one next to, it's going to be -15, right? So we can simplify this without using a calculator, and you know that if you square an answer, if you square something with the square root is just going to cancel the square, and we'll be left with the part inside, right? So the squaring the part at the top there is just going to give us only the 3, and squaring the part at the bottom, it's going to give us 2 squared, which is 4, right? When we simplify it, and now here we'll get +8 over 15, because that's negative over negative, and we know that it's just going to cancel the negatives, right? So here we can cross cancel these by simplifying these things, and if we take a look at the 3 can go into itself once, 3 can go into 15 5 times. So the 4 can go into itself once, and the 4 can go into the 8 2 times, right? So if you still remember this, it's something that you've done in the lower grades when you're simplifying fractions, right? And I think the answer would have given you that the value of 2 over 5. So we've solved the 5.1.3. Can we quickly now go to 5.1.3? So we can do that quickly. Oh, sorry about that, the numbering here, I think there's a problem. So this one is not 5.1.3 necessarily, I'm very sorry about that. This is A and this is B, right? So we've answered this one, and we've also answered this one. What we are just about to do is 5.1.3. So let's do it quickly. So the 5.1.3 question, they're saying that we have to solve, or we have to calculate the size of angle ROP correct to 2 decimal places, right? So if we take a look at this, this is an angle that is more than the beta. If you look at this, the beta is the angle. If I can erase this just to have some space. So if you can take a look at this, you can have the triangle here. The beta is the angle all the way from here to here. So that's like 180. So the angle from here to there is 180 plus this acute angle over here, right? So let's go and calculate the angle beta. How do we calculate the angle beta? We can make use of the equation here. So we had the equation here, the simplified equation, which was cos beta is equal to -15 over 17. So the cos of beta is equal to -15 over 17. So it means that the angle beta that we can calculate here, it's going to be the cos inverse. So if you say cos inverse on the calculator, the shift cos. So let's just use the calculator quickly just to check something. So we do have two options to solve the problem. So what we can do here is to first look at the 15 over 17. So let's ignore the negative. Let's look at the cos inverse of that. So we'll get cos shift cos of 15 over 17. The angle gives us 28, 07 degrees, right? So this is not the beta angle, right? Like I said, the beta angle here, the beta angle, which is the one we got here, which is the 28, it tells us the small acute angle that is inside the triangle, right? So the overall angle, it's going to be 180 plus the answer we got. Do you see that? So we have a Cartesian plane that looks like that. So since the line looks like this, so the angle beta is the angle from the positive x-axis all the way to the line, and the one that we've calculated here, it's the 28, which is this small one here, which we just simply add with the 180. So therefore the answer we got here, we're just gonna go and add this answer with 180 degrees, right? And the beta angle, it's going to be 180 plus the answer, which the answer is 208.07 degrees. So we've solved the question 5.1.3, and I think we can quickly move on to 5.2.1, these trigonometric equations. So let's do these ones quickly. So 5.2. So the 5.2 here, we are given tan of x, which is equal to 2,22. So because the tan, we have it on the calculator, we can simply take it that side. So we're going to say the angle x is equal to the tan, and then put the -1 there because we've transposed it to the right hand side, or we took it to the right hand side. And then let's punch the shift button, which is the top left of the calculator, shift, and then punch the tan, and then punch 2.22. You will see that the answer, it's going to give you the x value as 65.75 degrees. So that is the angle of x we get over there for the tan, right? So let's move on to the second question, 5.2.2. So we have the sec of x, the secant of x, with the, which is equal to 5 point. So what we need to remember here is that as much as we know that the sine theta, so what sec is, it's reciprocal, right? So what we need to remember is that we have trig ratios here, with the likes of the sine theta, right? And it's reciprocal. The reciprocal of sine theta, it's cosec, right? So what I'm going to do like this. So I'll say the sec theta is the same as 1 over cos theta. So you can, if you don't have these ones, you can write down. And then there's what is called cosec theta, which is simply 1 over sine theta. And then the cot theta is equal to 1 over the tan theta, right? So the challenge with this one is that we don't have the sec theta on the calculator. So if maybe you thought of getting the sec of the part on the right, we were not going to succeed by doing that. But what we can first do is to change the sec theta, just to make use of this. Change the sec theta into 1 over the cos of x plus 10 degrees, right? So that's the first thing we're doing there. We're changing the sec theta into the cos. So we're saying it's 1 over cos x plus 10 degrees. After that, we know that anything is over 1. Anything is over 1. And what we can just do here is we can do the reciprocals here. You can flip this, put the one at the top, put the one at the bottom, and that at the top. So if we apply the reciprocal here, we will get the cos of x plus 10 degrees will be equal to 1 over 5,759. And then now we know that this is the cos of x plus 10 degrees. So now it becomes easier to solve, because the part on the right, we can just quickly write it on the calculator just to simplify it, and we will get that it's 0,173641, and continues. So we can take the cos that side, can take the cos to the right hand side, and if we do that, we will be left with x plus 10 on the left, x plus 10 degrees, with the cosec, so with the shift cos of the part on the right, which is 0,17364. We put that inside the calculator. We say shift cos, then we punch those numbers inside. We'll get that the answer here on the right hand side, it's simply 80.00 degrees. If you transpose this 10 that side, we'll get that the x is going to be 80 minus 10, right? So the answer here is going to be 70 degrees, right? I hope you guys understand what we did here. The first thing that we did was to make use of the reciprocals. So if you're not familiar with the reciprocals, please write them down and practice these reciprocals, so that you know that when you see a different trig ratio, or if you see the reciprocals, you can simply change them to trig ratios and work with them, right? Because these are reciprocals of our trig ratios, right? Can we just quickly do the last one there, the sine, the 5.1.3. so this is 5.2, so the 5.2.3. so sine x over 0,2 minus 2 is equal to 1.24. So one thing we can do here that is very much important is just to transpose the 2 to the right hand side. And if we do that, we'll be left with the sine x over 0.2, which is equal to 1,24 plus 2. So the sine of x over 0,2 is equal to 1,24 plus 2, and the answer is 3,24. So the part at the part on the right, it's 3,24. And now what we can do is we can say anything is over 1. This one, the part on the right hand side, is equal to 1. It's over 1, sorry. And you can literally cross multiply that part. You will see that the sine x times 1, it's simply sine x, and then the 0,2 will multiply the 3,24. The answer will be 0,648, and we can take the sine to the right hand side, and if we do that, we'll be left with the x value here being the sine inverse or the shift sign. You press the shift, then you press sine, and then you punch the number inside, and then you close the brackets. So you say shift sine, and the answer is 40,39 degrees. So this is our angle we got, and I hope you've looked at how we calculate the equations, how we solve the trigonometric equations. So let's quickly now move on to the second part of the problem, right, so that we cover as much as we can here, right? So we will quickly just go into question 4, right? So question 4, so what we can do with the question 4, we have to try to read the information given and try to make it useful, right? So we're given that 4 cot theta plus, so we're given this part here, and we're given the second part over there, right? How do we make use of this information that's given? Right, they're saying the first question 4.1.1, it's saying that you have to use a sketch. So use a sketch, use a diagram, like the question we just worked on previously. It's just that the diagram was already drawn, and which was drawn on the third quadrant, right? So here we'll do some workings to just figure out where the diagram is supposed to be drawn, and we draw it, and after that we will be solving the questions, right? So let's now determine the value of the following. So we don't have to use a calculator, of course, right? So let's get straight into it. So we've got 4 cot theta. 4 cot theta plus 3 is equal to 0, right? So how do we deal with this? We can first get the trig ratio. So the trig ratio is going to be, we can transpose the 3 that side. Try to simplify this, and we'll get -3. Divide both sides by 4. If we divide both sides by 4, we will see that the 4 is going to cancel with the 4 here, and on the right hand side we'll have the cot of theta. So the cot of theta here is equal to -3/4, right? So we talked about the reciprocals, right? And I said to you guys that the reciprocals here, if you see the sec theta will be 1/cos theta, and the tan theta and the cosec theta, the cosec theta is going to be 1/the sine theta, right? And then the cot theta, which is the one we have here, it's like simply the reciprocal of the tan theta, right? So after you figured out that, oh, this cot here, it's the reciprocal of tan theta, so just imagine this cot theta. So this cot theta, if we do the reciprocal, is the same as tan theta minus 4/3. So if we do the reciprocal here, we know that this one was 4 cot theta. What is 4 cot theta? 4 cot theta is like 1/tan theta, right? So this came from 1/tan theta, and we know that on the right hand side we had -3/4. And now if we flip this, and we also flip on the right, we will see that the tan theta is going to be at the top, which is going to be over 1 here. And also we will flip, the 4 is going to go up and the 3 is going to come down. And this is what I have here, right? So with what I have now, I can draw the quadrant, right? So let's draw the quadrant. We don't even know where the quadrant is supposed to be exactly, but we can make use of relevant calculations and workings to find the specific quadrant where the diagram should lie, right? So let's take a look at this. So this is telling us that the tan should be negative. Where is tan negative? So if you take a look at your cast diagram, all students take coffee. Your cast diagram, all students take coffee. So it tells us that all trig ratios are positive, only sine is positive, only tan is positive, and only cos is positive, right? So if you take a look at this here, this is going to be 90 degrees, and this is 0 degrees, and this is 180 degrees, right? So this is 170 degrees and 360 degrees, right? So let's make let's look at where cos is negative and tick the quadrants where cos is where tan is negative. So where is tan negative? So tan is negative on this quadrant and that quadrant. So the problem now with this, it gives us two quadrants where the diagram can possibly be drawn, right? So we don't know where exactly the diagram can be drawn, so we will also make use of the second part, right? The second part tells you that the diagram should be drawn where the theta is between 0 degrees and 180 degrees. And if you take a look at 0 degrees and 180 degrees is this here, means that the angle can possibly be drawn on the first quadrant or on the second quadrant. So which quadrant has got most ticks? It's the second diagram. It's the second quadrant, right? So that's where the triangle can be drawn. So if the triangle is drawn in this quadrant, we can say the theta is here, and we can say the 90 degrees is here, and we can already talk about the tan here, and the tan has got an opposite at the top. So we know from SOHCAHTOA, the tan is opposite over adjacent. So what is the opposite side? It's 4. Is 4 positive or negative? Because it's going up, and we can see that the x is going to the left. So the fact that the x is going to the left here, the x is the one that gets to be negative. So the x is going to be negative 3, but the y is going to be positive 4, right? So the x is equal to this, and the y is equal to 4, right? I hope you guys understand what we're talking about here. We've already figured out where the diagram needs to be drawn, and you can see that the missing value here, it's the r, which is our hypotenuse, and we can quickly look for it from Pythagoras theorem, right? So let's use Pythagoras theorem to figure out where the hypotenuse side. X squared plus y squared is equal to r squared. So what is the x squared? X squared minus 3. What is the y? Y is positive 4 squared, which is equal to r squared. So here we're going to say negative 3 squared. It's going to give us 9 plus 16. This gives us value 25. And if we introduce the square root both sides, square root here and square root there, so there's no need to put the square root when you're looking for the hypotenuse side, which is the value of r. But it is very much important to put the plus minus when you're looking for either the x or the y values, missing values. So here the r is 5. So it means that this one here, it's positive 5, right? So now that we have worked out the positive 5, and we can answer any question, right? So by the way, here we're doing the first question. So all these workings here were done just to do the first question, right? And I think the first question was asking just for you to find the cos theta, and you can see that the cos theta here on the diagram, it is the hypotenuse side, it is the adjacent side over the hypotenuse side. So it's adjacent over the hypotenuse, and we can see that the cos here, cos of theta, cos of theta based on the diagram, the adjacent side, the one which is next to, it's minus 3, and the hypotenuse one is 5. Right, so this is minus 3 over 5. And now we can move on to B. So the question B, 4.1.1b, what we're supposed to do there is we have to evaluate the sine theta, we have to also evaluate the sec theta, and we also have to evaluate the tan of theta, right? So this is going to be 3 times some trig ratio here, times also another trig ratio here, and then another one at the bottom, right? So now what is sine theta? Sine theta based on the diagram, it's opposite. So if I can draw the triangle, I can draw the triangle separately, because I can see that that one there, it's a little bit complicated. It's got a lot of things in it. So we can just draw the triangle outside, as long as we pay attention to the signs of the triangle. So the theta is here, and the 90 degrees is here. So minus 3, this is the x, and the y value is 4, and the r value is 5, right? So let's work out the sine of theta. Sine of theta, it's going to be opposite over hypotenuse. So the opposite side is this one, and the hypotenuse side is that. So this is like 4 over 5. That's literally like 4 over 5. So sine theta is 4 over 5. So we know sec theta as a reciprocal for the cos, right? So, but the cos is what? Is adjacent over hypotenuse. It means that the sec theta, it's going to be hypotenuse over adjacent. So the reciprocals, what they do is, as much as we swap the trig ratios, we are going to swap also the values of the trig ratios, right? So to get the sec theta, we must swap the cos trig ratio. So it means that if we know what cos is on the diagram, and I think the cos is minus 3 over 5, we can see that the cos, we've already looked at it on the previous question, which was minus 3 over 5. So now it's going to be for the sec theta. The sec theta is going to be the hypotenuse side over the adjacent, and the hypotenuse side is 5. So it's going to be 5 over negative 3. That is what we got there for the tan theta, for the sec theta. So let's look at the tan theta. Tan theta is going to be opposite, right? Opposite over adjacent, and what it would be, it would be 4 over negative 3. So what we can do here is just to do some simplification here. How do we simplify this? We know that this is over 1, and we can see already that there's going to be some cancellations here with the values. So this is going to cancel that. So the 5 is going to cancel the 5. They said without using a calculator, so we'll try not to use a calculator. And the 5 will cancel the 5. The 3 here will also cancel with the 3 down there. So this will cancel with the 3 here. And now we'll be left with 1, 1, 1, 1 everywhere. So this is like 4, negative 4. We'll be left with negative 4 over 1, right? And the negative 4 over 1 is dividing 4 over minus 3, if you pay attention. So this over, this big over here, it's a division sign. We say divide, and then here we're going to have minus 4 over 1. You can change that to a times minus 3 over 4. And the answer is going to be a positive 3, because the 4 is going to cancel with the 4, and the negative times the negative. So this is 1, 1. And the answer is going to be 3 over 1, which is just 3, right? So you might have to watch that again just to make sure, or you can also double check it right? But I think that is the correct answer. Looking at the procedure that we follow there, should be correct. So let's take a look at 4.1.3, 4.1.2. They're saying that hence show that, so we have to show that the sine theta, the sine square theta minus 1 is equal to the negative cos square theta. So we have to show that. So we can take the left hand side. So the left hand side is equal to sine square theta minus 1. So if we try to work to do this one, so the sine square theta, what is the sine theta? Sine theta based on the triangle, it's the opposite side, which is 4 over 5. So we're looking at the triangle. This is 4 over 5. And then here, we will see that the 4 over 5, when we square the part at the top, it's 16 over 25 minus 1. So the left hand side here, we can still use the LCD. We know that anything is over 1. This one is over 1. And we know that the LCD here would have been 25. So we can put 25 here at the top and 25 here at the bottom. And the answer will give us negative 9 over 25. So this is what the left hand side gave us. So let's take a look at the right hand side. The right hand side is negative cos. It's negative cos theta. So negative cos theta here, it's going to be negative. What is the cos of theta? But it's being squared. So what is the cos of theta? Cos of theta, it's going to be 3, negative 3 on the diagram over 5, right? And it's being squared. The fact that it's being squared here, if we pay attention, we will notice that the part at the top, it's going to give us a positive 9 over the part at the bottom, it's going to be 25. So the answer here is negative 9 over 8. So it means that we've proved that the left hand side is equal to the right hand side. The left hand side is equal to the right hand side. So I need some space to do the 4.2 and the 4.3 question quickly. So I will just erase some of the things here. So I think you can just take a screenshot of these solutions here if you need them, or if you just didn't write them, but I'm just gonna erase this part. So let's erase this quickly. So let's quickly do 4.2 and 4.3. So 4.2 here, we have cos of 30 degrees times the tan of 60 degrees plus the cosec square of 45 degrees, which is the same as the sine and timesing the sine of square 60 degrees. So I said when we're working with special triangles, just recall that the sine of 30 degrees is 1 over it's 1 over 2. So you must just recall that the sine of 30 degrees is 1 over 2. And after that you can draw the triangle 1 over 2. And also recall that the cos of 30 degrees is root 3 over 2. So it means that already you can see it there, right? But we can just say 30 degrees here. And after the 30 degrees here, we can see that this is the opposite side. And this is the hypotenuse side. Opposite side, it's going to be 1. Opposite the 30 degrees, it's 1. hypotenuse is the 2, and looking at this, the adjacent side is the root 3, and we can put root 3 there. And after that we can say the hypotenuse is also 2, but it's already there, so I'm not gonna write the 2 there because it's already there. And after that we just write 60 degrees here, right? So this triangle here is our special triangle that we can use to evaluate any trig ratio that will be having the special angles 30 degrees and 60 degrees, right? So the cos of 30 here, cos of 30 is root 3 over 2, and the tan of 60, it's going to be opposite the 60 degrees over adjacent. So the tan is O over A, which is opposite over adjacent, and which is going to be root 3 over 1 plus, so the cosec of 45, the cosec is this, is the reciprocal for the sine. So it means that we just get the sine theta and then we get its reciprocal, we flip it, right? So what is the sine here? Sine is sine of 45, so we must look at the sine of 45. So let's quickly draw the special triangle for 45. So with the special triangle for 45, I can just advise that you recall that the sine of 45 degrees is 1 over root 2, and then after that you say this is 90 degrees, so this is, you say 1 root 2, because it would have been opposite over hypotenuse, and the cos of 45 is also 1 over root 2. So if you remember that, I think it will be perfect, because you can work with anything, right? So the sine of 45, it's 1 over root 2. We just get its reciprocal, so it's going to be root 2 over 1, and it's being squared, times the sine of 60 degrees. So the sine of 60 degrees from here, it's going to be opposite over hypotenuse. So it's opposite the root 3, which is opposite over the hypotenuse side. So after this, we can just simplify this. How do we simplify this without using a calculator? Root 3 times root 3, 2 times 1. I will get 3 over 2 plus 2 over 1 times root 3 over 2. So if you take a look at this, we can just simplify this by saying 3 over 2 plus 2 root 3 over 2, and the final answer here, it's going to be the LCD. Since it's the same, we're just gonna add the parts at the top, and I think we'll get 3 plus 2 root 3, 2 root 3. So with the 4.3 question, I will quickly just erase the part. So let's just double check if that one is correct. So the first one is root 3 over 2, and the tan 60, it's the root 3 over 1. The cosec, it's going to be the reciprocal of the sine 45, which is going to be root 3 over 1, and it's getting squared. Yes, we just forgot to square this one as well, so I'm sorry about that. I think so let's just quick fix this one. So when we fix this, we're just gonna get 3 over 2 plus 2 over 1 times 3 over 4, right? Because you're gonna square the part at the top and square the part at the bottom, and we'll get that here, it's 3 over 2 plus, so if we can simplify this part here, we can cross cancel. 2 goes into itself once, 2 goes into 4 2 times, and if we multiply 1 times 3 and 1 times 2, we will get 3 over 2, and 3 over 2 is the same as 3 plus 3 all over 2, which is like 6 over 2, which is the same as 3. So the right answer for this one was 6 over 2, which was just equal to 3, right? So let's quickly do 4.4. 3. So I'll erase this part here on the right. So it's a very short question, that one. We can finish it quickly so that we know that we're done with the 2 questions. So we have 4 over 3 sine theta, which is equal to the cos of 37 degrees. What we can do is we can just divide both sides by 4 over 3. This cancels that, and then we're left with the sine of theta. So if you say this side is cos 37, cos 37 divided by 4 over 3 will give you 0.5989766, right? So the theta here, you take the sign that side and get the shift sign of 0.5897. Then you punch that on the calculator. Shift sign the angle, and the angle is 36,80 degrees. And I think it's perfectly fine there with the questions that we've done. I just hope that you guys are gonna watch this video over and over just to make sure you understand some of the steps that are followed to solve the problems, right? So there's a question that you can also do over here, so you can attempt this question by yourself. I think you must have learned, and you will be able to solve the questions by yourself. Thank you, and bye bye. See you on the next video.